Assalamualaikum and greetings to everyone in this cloud session. I would like to quickly introduce myself. I am Wan Mohd Eqhwan Iskandar bin Wan Saiful Bahri from DRB-HICOM University of Automotive, Malaysia. Today I would like to share with you about my recent research with the given title Study on Rheological and Stability of Natural Derived Carbon Nanosphere Nanofluids. Without further ado, let's begin. Did you know that rice husk was one of the major waste products in Malaysia? In fact, there are around 2.5 million tonnes of rice husk were produced as for July 2021, in which can gain approximately 1.4 million kilograms of rice husk, and from that number can potentially produce 140,000 kilograms of carbon char. Somehow, this rice husk can be tuned into fine product through fuel process. Rice husk can produce a charcoal through carbonization process. Apart from that, fuel treatment and process can tune the charcoal into carbon nanosphere. This carbon nanosphere could be potentially used in developing green nanofluid in which it can enhance the properties of the base fluid. The problem is the obtained carbon char is waste that we can get during the Rheological process. The carbon char will be dumped in the landfill and some of the carbon chars will incinerate for electricity generation, which will cause pollution to our environment. Furthermore, poor performance of base fluids may cause a bad idea since it is not derived from a green resource and cannot be disposed as it contains hazardous chemicals. So the next one is objective. So the first objective for this study is to characterize the surface morphology of carbon nanosphere nanofluids. And the second one is to investigate the rheological and stability properties of the carbon nanosphere nanofluids. Meanwhile, for the scope study, there are 4 scope studies in this study. The first one is to prepare the CNS from waste rice husk through chemical treatment and calcination process. The second one is to characterize the CNS by using the SEM. The third one is to prepare the CNS nanofluid by in ethylene glycol and water, which is called as a binary mixture. The last one is study the effect of CNS composition on rheological and stability properties. So for the methodology, we will start the preparation of carbon nanosphere. In this method, the rice husk will sun-dried to reduce the moisture content. After drying, rice husk was prepared for carbonization process. For carbonization process, the rice husk was treated using furnace with temperature controller. The thermal decomposition temperature is below 300 degrees Celsius. The carbonized rice husk, which is I call as CRH, were obtained from carbonization process were further treated using the sodium hydroxide with the purpose of obtaining a high surface area and removing the impurities. After the treatment, the CRH was filtered, washed with the eye water until the filtrate was neutral, and again dried at 60 degrees Celsius for 10 hours. The samples were further calcined in a tubular furnace under constant nitrogen flow to obtain CNS. For the characterization of CNS, the CNS nanoparticle will be characterized by using the SEM. Next one is the preparation of CNS nanofluid. In this method, the samples were prepared by using two-step method. Ethylene glycol and water will be the binary mixture with the ratio of 50 to 50. To reduce the agglomeration, ultrasound technique were introduced to produce the CNS nanofluid. The obtained CNS nanofluids were further characterized through rheometer and UVVs to determine the rheology behavior and stability of the nanofluids. The obtained data from the characterization will be analyzed and discussed. Moving to the results, figure in the slide showing the SM images for CNS. As can be seen on the slide, the CNS are present in conglomeration of sphere. Moreover, it can be observed that carbon nanotube appear in irregular spherical shapes with different sizes. The diameter of carbon nanotube calculated have a range of 84.04 to 834.86 nanometer with an average diameter around 315.52 nanometer. Furthermore, the carbon nanosphere tend to agglomerate when their diameters are less than 1000 nanometer to form bed necklace-like structures. For rheological study, the samples with different concentration were prepared. Figure A on the left side shows the flow curves of carbon nanoparticle in binary mixture nanofluid with various volume fraction of particles. It can be seen that with the shear rate, the shear stress improves linearly. The result also verified that binary mixture itself already shows the improvement of fluids and it is significantly increased with the addition of CNS with only a small portion, which is 0.02 volume percent. Meanwhile, for figure B on the right side shows the dependence of viscosity against shear rate. The results show that the viscosity increased with the increasing of nanoparticle concentration in the suspension. Thus, this will improve the properties of the base fluid. In this slide, stability of nanofluid will be discussed using the UVVs. From this figure, A on the left side, it can be seen that the peak of absorbance sits at the wavelength of 225 nanometer, presenting the existence of carbon nanoparticles. Meanwhile, from the right side, Referring to the procedure range, on the figure B on the right side is proven that the carbon nanofluid becomes stable and improves the properties of the base fluid. Furthermore, there are no precipitation starting from the fresh sample until week 7. So for the conclusion, green nanofluid with low concentration of nanoparticle has been successfully prepared. It is called as green nanofluid due to the raw material came from waste rice husk, and basically this study was a waste to wealth project. Apart from that, we can see that from the characterization of nanofluid, it is proven that the nanofluid can improve the properties of the base fluid. For future application, the suitability of CNS nanofluid as nanocoolant could create a new automotive market. I think that's all for me. Thank you so much.